सब्सक्राइब कीजिए चैनल स्नेहलता शर्मा को और बेल आइकन को दबाइए लेटेस्ट वीडियो सबसे पहले देखने के लिए।
हेलो स्टूडेंट्स, वेलकम बैक। स्वागत है आप सभी का। आज इस वीडियो में हम सेकंड चैप्टर होल नंबर्स के बारे में डिस्कस करेंगे। कंप्लीट चैप्टर एट अ ग्लैंस, होल नंबर्स चैप्टर का पूरा रिवीजन। तो स्टार्ट करते हैं नेचुरल नंबर्स से। ऑल द पॉजिटिव काउंटिंग नंबर्स स्टार्टिंग फ्रॉम 1 आर कॉल्ड नेचुरल नंबर्स। सो द एग्जाम्पल ऑफ फर्स्ट 10 नेचुरल नंबर्स आर 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and this list will continue and goes on till infinity. The second topic here is predecessor and successor. If we add 1 to any natural number, we get the next number, which is called successor of that number. For example, we have 12. If we add 1 to it, we get 13, and 13 is the successor of 12. Now let us define predecessor. If we subtract 1 from any natural number, we get the predecessor of that number. For example, the number 12. If we subtract 1 from 12, we get the predecessor of 12. So, 11 is the predecessor of 12. Also note that there is no predecessor of 1 in natural numbers. Now, the next topic is whole numbers. Whole numbers are the collection of natural numbers including 0. So, 0 is the predecessor of 1 in whole numbers. We have two sets. The set 1 is of natural numbers, which starts from 1, 2, 3 and goes on till infinity. To this collection, if 0 is added, we get a big collection of numbers that is called whole numbers. Collection of whole numbers includes 0 and all the natural numbers. Next topic is number line. How to represent whole numbers on number line. To draw a number line, we follow these steps. Number 1, draw a line and mark a point 0 on it. So, this is a line and on this line, we put 0 here. Now, mark the second point to the right of 0 and label it at 1. So, on right of 0, this is 1. Now, the distance between 0 and 1 is called the unit distance. Now, you can mark other points as 2, 3, 4 and so on with the unit distance. So, after 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this will go on till infinity. This is the number line for whole numbers. It starts from 0 and goes on till infinity. Now, the distance between 2 points. The distance between 2 points, that is 3 and 5, it is 2 units. You can see in the figure, this is 3. From here to here, this is 1 unit. And from 4 to 5, this is 2 units. So, distance between 3 and 5 is 2 units. Second topic is the greater number on the number line. So, the number on the right is always greater than the number on the left. Let us learn by taking two examples. Suppose we have two whole numbers. This is 2 and this is 5. Out of 2 and 5, the number 5 is on the right on the number line. So, 5 is greater than 2. Next topic is the smaller number on the number line. So, the number on the left of any number is always smaller than that number. Let us learn this concept by taking an example. Suppose we have two numbers, 3 and 7. Out of these two numbers, we can see clearly that 3 is on the left of 7. So, 3 is smaller than 7. So, we can write this as 3 is less than 7. Now, the next topic. Next topic here is addition on the number line. So, to learn addition on number line, we will start by taking an example. Suppose we need to add 2 and 5 on the number line. So, we will make a number line starting with 0 and we start with 2. The first whole number is 2 here. So, we will start with 2 and the next number is 5. So, we'll make 5 jumps to the right because we are adding. So, this is 1, 2, 3, 4 and 5. After 5 jumps, we will reach 7 and so is our answer. The sum of 2 and 5 is 7. Next topic is subtraction on the number line. To learn subtraction on number line, again we will take an example. Suppose if we have to subtract 6 from 10, so we will start with 10 Here is the 10. Since we are subtracting, we will move towards left. And since we need to subtract 6 from 10, so we will make 6 jumps to the left. This is 1, 2, 3, 4, 5, 6. And after 6 jumps, we will reach 4. So the subtraction of 6 from 10 is 4. Now the next topic. Next topic is multiplication on the number line. To learn multiplication on number line, again we will take an example. If we have to multiply 4 and 3, then we start from 0. Here is 0 and we will make 4 jumps using 3 units at a time. So in first jump with 3 units we will reach 3. Again in second jump with 3 units we will reach 6. Again in third jump with 3 units we will reach 9. And similarly the fourth jump with 3 units we will reach 12. So 12 is our answer. I hope that all the operations on number line like addition, multiplication, subtraction are clear to you now. Now we will learn about properties of whole numbers. The first property is closure property. Two whole numbers are said to be closed if their operation is also a whole number. Let us learn this closure property for all the operations. The first operation is addition. Whole numbers are closed under addition as their sum is also a whole number. We will learn this by taking an example. For an example, let us take two whole numbers, 2 and 5. If we add these two whole numbers, we get 7. 7 is also an whole number. So we can say that whole numbers are closed under addition as their sum is also a whole number. The second operation is subtraction. For subtraction, let us take two examples. If we subtract 2 from 9, we get 7, which is a whole number. And if we do the reverse, if we subtract 9 from 2, we get minus 7, which is not a whole number. So we can say that whole numbers are not closed under subtraction as their difference is not always a whole number. The next operation is multiplication. For multiplication, again we will take an example. For example, if we need to multiply 9 by 5, the product is 45, which is again a whole number. So we can say that whole numbers are closed under multiplication as their product is also a whole number. Now the next operation, division. For division, whole numbers are not closed as their result is not always a whole number. For example, if we divide 5 by 1, we get 5 and which is a whole number. But if we divide 5 by 2, it will be a fraction, not a whole number. So for divisions, whole numbers are not closed. So let us summarize. Whole numbers are closed under addition and multiplication but not under subtraction and division. Next property is commutative property. Two whole numbers are said to be commutative if their result remains same. If we swap the position of numbers. For example, let us take the operation addition. For this operation addition, let us take an example of two whole numbers. Suppose 2 and 5. If we add 2 to 5, we get 7 and the same result we will obtain if we add 5 to 2. So we can say that the addition is commutative for whole numbers as their sum remains same even if we interchange the position of numbers. Next topic is subtraction. Let us see whether whole numbers are commutative for subtraction or not. For that, I will take an example of 9 and 2. If I subtract 2 from 9, I get 7 and if I subtract 9 from 2, I get minus 7, which is not a whole number. So we can say that subtraction is not commutative for whole numbers as their difference may be different if we interchange the position of numbers. Let us now see for multiplication and division. For multiplication, let us take an example 9 and 5. If I multiply 9 and 5, I get the result 45 and the same result is obtained if I swap the position of 5 and 9. Now I am multiplying 5 by 9 and the result is 45 again. So I can say that multiplication is commutative for whole numbers as their product remains same even if we interchange the position of numbers. The next operation is division. For division also, let us take an example. Suppose 5 divided by 5. I get the whole number 5 and when I swap the positions, 1 in place of 5 and 5 in place of 1. Now I am dividing 1 by 5, which is a fraction and not a whole number. So we can say that division is not commutative for whole numbers, as their result may be different if we interchange the position of numbers. I hope commutative property is clear to you. Now let us move to associative property. The two whole numbers are said to be associative if the result remains same even if we interchange the grouping of numbers. Let us learn this for operation addition. Let us take an example of three whole numbers. Suppose I have three whole numbers 3, 2 and 5. For first case, I will group 2 and 5 together and the sum of 2 and 5 is 7. So 3 plus 7, this gives me 10. For second case, I will group 3 and 2 together and 5 as a separate entity. Now if I add 3 and 2, I get 5 and the second number 5. If I add these two together, again I get 10. So we can say that addition is associative for whole numbers, as their sum remains same even if we interchange the grouping of numbers. Now let us see for subtraction whether whole numbers are associative under subtraction or not. For subtraction, I will take another example. Suppose I have 8, 10 and 2. Now for first grouping, it is 10 minus 2, which gives me 8. So 8 minus 8, this gives me 0. For second example, I will group 8 and 10 together. So 8 minus 10, this gives me minus 2 and minus 2. This gives me minus 4. So both the results are different. Since the results are different, we can say that subtraction is not associative for whole numbers, as their difference may change if we change the grouping of numbers. Now let us learn whether whole numbers are associative for multiplication or not. To see multiplication is associative for whole numbers, I will again take three whole numbers 3, 5 and 2. First I will group 5 and 2 together. 5 multiplied by 2, this gives me 10. So 3 multiplied by 10, this gives me 30. Now I will group these whole numbers differently. I will put first two whole numbers together. So 3 multiplied by 5, this gives me 15. And 15 multiplied by 2, this gives me 30. Clearly we can see that multiplication is associative for whole numbers. We are getting the same result even if we change the grouping of numbers. Now let us see this for division. For division, let us take an example. 24 divide by 6 divide by 2. For this, let us group 6 and 2 together. If I divide 6 by 2, I get 3. So 24 divide by 3, this gives me 8. For next grouping, I will group 24 and 6 together. So 24 divide by 6 divide by 2. When I divide 24 by 6, I get 4 and 4 divide by 2, this gives me 2. So clearly you can see that division is not associative for whole numbers, as their result is different for different grouping. Now let us learn the next property. Distributivity of multiplication over addition. This is very important property. This property says that if we have three whole numbers x, y and z, then x multiplied by y plus z gives me xy plus xz. In this, x is multiplied to both y and z. First I multiplied x by y, secondly I multiplied x by z. Now let us use this distributive property to solve problems. For example, 15 multiplied by 45. So 45 can be split as 40 plus 5. Here we can use the distributive property. 15 here will get multiplied with both 40 and 5. So first of all 50 multiplied by 40, then the addition sign in between, and then I will multiply 15 by 5. So 15 multiplied by 40, this gives me 600. And 15 multiplied by 5, this gives me 75. And if I add these two together, I get 675. This is how we use distributive property. The next property is identity for addition. Identity for addition means any number which we add to the number and we get the same result. If we add 0 to any whole number, the result will be the same number only. So 0 is the additive identity for whole numbers. For example, you can see a is any whole number, and if I add 0 to it, I get the same whole number a again. This I have shown by picture also. 2 is a whole number. In this bowl we have 2 apples. The next bowl, this is empty, and if we add these two together, I get 2 only. This clearly shows that if we add 0 apples to 2 apples, we get the 2 apples only. So 0 is the additive identity for addition. Now let us learn additive identity for multiplication. If we multiply 1 to any whole number, the result will be the same whole number. So 1 is the multiplicative identity for whole numbers. Here I have shown this is A. When we multiply A by 1, which is a multiplicative identity, we get the same whole number. This can be done in any order. If we multiply A to 1, again we get the same whole number A. Now let us learn about patterns. Patterns are used for easy verbal calculations and to understand the numbers better. We can arrange the numbers using dot in any elementary shapes like triangle, square, rectangle, line, etc. These are the examples of arranging dots in the form of numbers in a single line. In the next example, we are arranging numbers using rectangles. 6 we can arrange in rectangular form like this. Similarly, 12 can be arranged like this. Here we arranged 3 dots in row and 4 dots in column. So this is a rectangular array. Similarly, we can arrange some numbers using squares. For example, 9. Here we have 3 rows and 3 columns. Similarly, the number 16 can also be arranged in the form of square. We have 4 rows and 4 columns. Now, we can arrange some numbers using triangles. For example, 3 can be arranged like this, 6 can be arranged like this, and 10 can be arranged like this. Now, we will learn how to use these number patterns. Patterns can be used to simplify the process. Here you can see. If we need to add 9 to 123, we can write 9 as 10 minus 1. Now it is very easy to add 10 to 123. This gives me 133, and 1 less than 133 is 132. Like this we use patterns to simplify the process. Let us see some more examples. 123 plus 99. Here 99 can be written as 100 minus 1. And 123 plus 100, this gives me 223, and 1 less than 223 is 222. Second example is to simplify multiplication process. So here 83 multiplied by 9. This 9 can be written as 10 minus 9. Now I will use distributive property. 83 multiplied by 10, this gives me 830, and 83 multiplied by 1, this gives me 83. Now I will subtract these two and get the resultant 747. Another example of multiplication process, 83 multiplied by 99. Here instead of 99, I write 100 minus 1. Now 83 multiplied by 100, this gives me 8300, and 83 multiplied by 1, this gives me 83. Now I will subtract these two and 8217 will be the answer. So by now you have learned that observation of number patterns can guide us in simplifying the processes and makes our calculations easier. I hope this video has helped you. We'll meet in a new video with another concept. Till then, keep learning, keep sharing. Thank you.